Hello, ladies and gentlemen. Welcome to 1.4 of Geometry A. So right now we're talking about angle measure. So that's kind of what we're looking at. So two things to know about. The one's called a ray. An array starts at one point and goes infinitely in one direction. So ray, if I was going to say ray WX, it would be like that. Okay, ray WX. That would imply that I start at W and I go towards X and I go on forever. So it would look something like this. This is W, this is X, and hopefully your line is a lot straighter than mine. I apologize. So this is a ray. Notice there is no arrow going the other direction. Okay, so two rays make an angle. Okay, so two rays make an angle. So an angle created like this. There's a vertex and there are two sides. So two non-collinear rays make up your sides, and your common point is called your vertex. So your common point is called your vertex, and your sides are rays. All right, so if I make angle ABC, wow, that was terrible. Let me try that again. ABC, like so. All right, there's A, B, C. I would say angle A, B, C, or I could say angle C, B, A. All right, those are kind of my three choices there. Now, bringing about this, an angle divides a plane into three distinct parts. Okay, A, C, B, and D are on the angle. Okay, they help make up the angle. Point A would be exterior of the angle. Point E is going to be on the interior angle. Think exterior, interior of a house. Exterior is the outside, interior is the inside. So that kind of breaks up. You're either one of three things. You're either on the angle, on the interior, or the exterior of the angle. Those are your three things. So again, exterior out, interior in, or you're on the angle. So if I look at this, name a point on the exterior of D, E, B, that angle right there. A point on the exterior, I would be looking at either G or F. Both of those would be on the exterior. What are the sides of angle 5? Well, angle 5 would be this. Notice how it's named by the number on the inside. Okay, named on the number on the inside. So my sides are going to be ray BG, and I'm going to say ray BE. Okay, those are going to be my two sides. So another name for 7, for angle 7 would be angle 7, ABD. So instead of ABD, I would, instead of angle 7, I would call it angle ABD. Okay, I could also call it angle DBA. Either way is technically correct, as long as B is in the middle, showing that that is the vertex. So I just got to have B in the middle somewhere. So if I take a look at this, this is an actual protractor. So let's zoom in a little bit. So as a protractor, it's got some lines marked. I need to figure out their angle in degrees. Notice a couple things. One, notice I've got two marks, one in red, one in black, and those are ways to measure angles, so that way you can measure from either direction. So straight horizontally is an angle of 0 or an angle of 180. All right, straight up and down is going to be 90 for both degrees. So now I'm trying to figure out how big these angles are. So for CAB is that angle right there. Well, I go from 0 to 10, or 180 to 170, so that's going to be 10 degrees. Okay, so for DAB, if I start at 0, I go up here. So if I start from this point, I go up to here. That appears to be about 1, 2, 3. That appears to be 83 degrees. But Mr. Heeren, why am I starting there? Why can't I start from here and go this way and get an answer of, 97 degrees? Well, the answer is because I started here, all right? I come down this way. I don't come from this angle. So I've got to look at what I'm dealing with. So EAB, EA, still looking at point B out here. Okay, so that's that angle. So now I start here, I go back all the way to here. So I can start at the black 0, come all the way around. I'm almost to 130, not quite. I'm back 1, 2, 3. So that's going to be 127. Notice I go past 90 degrees, so it's going to be bigger than 90 degrees. All right? So now, let's take a look at a different one. Let's take a look at the next one. CAF, CAF. If I look at that angle, that's a very, very big angle. Okay, but now this time I want to start from this side and work back. So I'm going to go all the way back here. So it's not going to be a full 180. It's going to be 10 degrees short. So that's going to be 170 degrees. And the way I did that, I started from the red and I kept counting by tens all the way around until I got here. So for DAF, D is right here, AF. So DAF, so starting from here going back, so I go to 90, I go past, I go to 95, 1, 2, that's going to be 97 degrees. And then my last one, EAF, EAF, again, starting at 0, going up, so 10, 20, 30, 40, 50, 1, 2, 3, that's going to be 53 degrees. So I'm always starting from this side or this side, and I'm just going to where it stops, and I'm counting how many degrees that goes. That's all I'm doing. So take a second and look at those answers. Woo. All right, so let's go over to the second page here. So classifying angles, naming angles. Okay, you're naming angles by the type of angle. So this, you see that little red square? That indicates that that is going to be 90 degrees. Yeah, come on. All right, and that's going to be considered a right angle. So I put right or RT, or I can write right. Either way would be fine. This angle, since it is clearly smaller than 90, I'm going to call that acute. Okay, and the measure has got to be less than 90 degrees. This one, clearly much bigger than 90 degrees, so that's going to be much bigger, so I'm going to call that obtuse. So this last one makes a straight line. So straight lines get called straight angles. So that's going to be 180 degrees. So that's going to be a perfect line, so that's going to get called a straight angle. So if I take a look, SYT, SYT is right there. That is quite obviously acute. It's not even close to right. It's definitely not obtuse. We're going to call that acute. SYX, I'm looking at this angle here. Clearly bigger than 90, so I'm going to call that obtuse. Okay, bisector, an angle bisector. Bisector is a word you should definitely get familiar with because bi means two, correct? I really hope you're nodding your head yes. So bi means two. Think bicycle has got, two wheels. And, it's got pedals. I'm sorry, that is the ugliest bicycle in the history of the world, but bicycles have got two wheels, right, and spokes. So a bicycle has two wheels. So bi cuts into two, okay? So angle bisector means cuts this into two equal parts. So this is congruent to this. They have the same measure, all right? So WXY is congruent to ZXY. So anytime you see this word bisects, you've got to know, hey, that cuts it in half. So KN bisects JKL. So that means this and this are the same length. JKN is this angle. That's saying that's 8x minus 13. NKL is 6x plus 11. So those are my two, so they are bisected, they are equal, so I want to set them equal to each other and solve it. So, little two-step algebra. Why did I do that step? That's not a very smart step. I want to keep the variable positive. 0, 0. 2x, 24, x is 12. But that doesn't answer my question. My question says, how big is JKN? Well, JKN is 8 times 12 minus 13. So that's going to be 96 minus 13. So that's going to be 83. So, given QS bisects PQT. So this one, they don't even give you a picture. That's kind of mean. So we have got PQT and QS bisects it. So PQT is 6x plus 4. So this whole thing, 6x plus 4. TQS, this little part, is 7x minus 2. So now if this is 7x minus 2, this is also 7x minus 2. So these two together add up to 6x plus 4. So 14x minus 4, add these two together, gives me 6x plus 4. So a little solving will give me, come on, add 4, subtract 6x, subtract 6x, zeros, 8x equals 8. So I'm really hoping that it hasn't been too long and you tell me x equals 1. But that doesn't tell me everything. I got to figure out how big PQT is. So PQT is that whole angle, so I'm going to take 6 times 1 plus 4. That gives me 10. All right, that is all the notes. Please come talk to me the questions and make sure you understand what you're doing.